Hey guys, this is the homework assignment that I handed out on the day 3 lesson for this week. So if you missed class, you can print this out in Canvas. I'm also going to go over a few of these problems and a few of the key ideas from today. Before we get into these problems, let's talk about those key ideas. The first thing we need to talk about is what's called an inscribed angle. Okay, the word inscribed literally means written inside. So think of that word scribe means like to write, and in is like inside. So inscribed is written inside. So an inscribed angle is an angle inside the circle, but specifically the vertex is on the circle itself. Okay, so this guy, for example, is an inscribed angle. Okay, now the reason why I drew two circles here is because I want to contrast this with another idea that we have, which is called a central angle. Okay, a central angle is inside a circle as well, but the central angle has its vertex in the center. Okay, so inscribed vertex is on the edge of the circle. Central angle is the vertex is in the center of the circle. So this is inscribed, and this is a central angle. Okay, the other thing that's a little bit different is how the arcs are related to the angles. Okay, so for central angles, we know that, let's say this is a 45-degree angle. We know that this arc measurement is also 45 degrees. In other words, they match. That's not true for inscribed angles. The relationship is a little different. In this case, if this guy's 45-degree central angle, the arc measurement is actually 2 times bigger. It's 90 degrees. And that's true for any inscribed angle. Okay, so that brings us to this idea, this inscribed angle theorem. Now this is a theorem we proved in class, but part of that proof is in your textbook. So if you missed class today, I would recommend looking at that proof, which is on page 545 in your book, and just be kind of familiar with it, because I may, ask you a question on the test or quiz. So just make sure you understand that, and I would put that in your notebook if you missed. If you were in class today, we did that together. Okay. The inscribed angle theorem is basically this idea here. So let me give you kind of the wording to it. It's actually on page 544 if you want to go there and check it out, but I'll write it down for you here as well. It goes something like this. If an angle is inscribed in a circle, then the measure of the angle is half the measure of its intercepted arc. Okay, so I'm going to underline this so it stands out a little bit. If an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. So in this case, what it's saying is if this angle is inscribed in a circle, which it is, then its measure is half of the arc, the intercepted arc. So this is 90 divided by 2, you get 40. Okay, but that works both ways. So another way to say it is, or the arc measure is double the angle measure. Those are kind of equivalent, right? So either double the inscribed angle to get the arc measure, or divide the arc measure by 2 to get the inscribed angle measure. Okay? We're going to use that idea on our homework a little bit, so let's kind of stop there. We have a couple more ideas to talk about, but we'll kind of stop there for now. And we'll switch gears, we'll jump over into this homework assignment, and we'll use that idea on a couple of these problems. Okay, so let's start out kind of easy here. We got angle, we got arc, and we got a missing angle measurement. Okay, one of the things we know is that all the arcs have to add up to 360, right? So this guy plus this guy plus this guy has to equal 360. Okay, what that means is we can take away these two measurements, these two arc measurements from 360 to get the missing arc measurement. So 360, we're going to subtract the sum of 72 and 152, whatever that is, we're going to subtract from 360. So I'm going to do that really quick. And that's going to give us 136 degrees for this arc measure. Okay? Now that's not what we wanted to find, but we still needed that. What we're asked to find here is this angle. Well, if this is the intercepted arc and this is an inscribed angle, remember this is going to be half of this. So we need to take 136 and divide it by 2. And that's going to equal 68. Okay, so that got 68 degrees, and that's what we're asked to find. Okay, let's take a look at this guy really quick. Okay, same kind of idea. We got a few angles and a few arcs. We want to find this arc, and we can use this angle to kind of help us do that. So if I double 68, I should get this full arc right here. Okay, so this full arc from R over to J is whatever 68 times 2 is. That's going to be 136, I think. Yep. Oh, same numbers as over here. Interesting. Okay, so this whole guy right here is 136. Okay. Now over here, we have this other arc that we can use. So 88, if we double that, we're going to get this full arc from here to here. Okay. So if we double 88, we get that full thing. So 88 times 2 is going to be 176. Okay. So if we take 176 and we subtract 86, we get just this piece. So we're going to take this whole 176 and we'll subtract this piece of it and we'll get just this guy. So 176 minus 86 is 90. Okay, so that means this guy, R to Q, is 90 degrees. And now remember that we know that this guy, sorry, I should kind of drew this funny, but this guy around here, this is 136. So if this full thing is 136 and this piece is 90, I got to do 136 minus 90. So 136 minus 90, 46. Okay, so this arc from Q to J is 46 degrees. So just kind of start with what you have and start building it up, right? Double 68, you get this full arc. Double 88, you get this full arc. Start subtracting to figure out what you have for the missing pieces, and eventually you're going to get the arc measurement that you need. Okay, now some of these have expressions in them, and that's okay. We're going to still use that fact to put it together and find some missing stuff. Now we're going to have to set up an equation, and the relationship between this inscribed angle and this intercepted arc is that if I double this, I get this. So I'm going to take this guy and double it, 2 times 16x plus 1, and I'm going to set it equal to the expression that they have for the arc measure. So 2 times this angle should equal this degree measure. So 2 times 16 is going to be 32x, and then 2 times 1 is 2, just distributing here. Right, and now we have to solve for x. So if I subtract 32 from both sides, I'm going to get 2 equals x minus 2, and then I add 2 to both sides, and I get 4 equals x. Now that's not what they wanted us to find. We wanted to find the measure of an arc, RS. But now that we have x, we can put it back in. So if I plug 4 back into this expression, I should get the measure of this arc. So 33 times 4 minus 2 is equal to the arc measurement that I'm after. I'm just going to do that really quick. That comes out to 130 degrees. Okay. Now this next one, number 7 here, is a similar idea, but there's a little bit more going on. Let's start with what we know. Let's start with the fact that we got. We got an inscribed angle here, and if we double it, we're going to get the measure of this arc. Now notice that arc doesn't have a measurement yet, so let's just go ahead and double this. So I'm going to do 2 times 4x minus 1. Okay, 2 times 4x is 8x, and then 2 times 1 is 2, so I have this guy, this full arc, is 8x minus 2. Now if you think about it, I have this arc, and this arc, and this arc. And if you add all three together, you're getting all the way around the circle. So what I'm going to do is I'm going to take those 3 arc measurements, put them all together, running out of room here, and set that equal to 360. Shoot, I should have given myself a little bit more room. 8x minus 2 plus 7x minus 12 plus 9x plus 14 equals 360. Okay. Now we need to combine like terms. We need to get x by itself, just normal solving stuff. So there's our 3 x terms. And if we put those together, we're going to get 24x. If we combine the number part, it looks like we're just going to get 0. So negative 2, negative 12, that's negative 14. Combine that with a positive 14, you're going to get 0. So that works out pretty nice. Now we got to divide both sides of our equation by 24, and then we're going to get x equals 15. Okay, again, not the final answer, definitely something we need though. As you're going here, make sure you show your work, because actually this equation tells me a lot more about what you know than the final answer. Even though the final answer is important, this shows me you understand the relationships that we're talking about, which is kind of the new idea. Okay, now that we have x equals 15, we're going to go back and see what we actually want to find, which is the measure of an arc, Vx. This guy right here. So I'm going to use that expression, and I'm going to plug in 15 in for x, and that should give me the measure of Vx. So 7 times 15 minus 12. Looks like that's 93. Remember, we're in degree measurements here, so 93 degrees. Arc measure. All right. Before we get too much farther, let's go and talk about some more ideas about inscribed angles. Okay. Another thing that is talked about in chapter 10 is what's called inscribed polygons. Okay. Remember, inscribed means written inside. So what we're going to do is we're going to draw an inscribed quadrilateral. Okay. Quadrilateral is a polygon with 4 sides. So I'm just going to put some kind of random points here on the circle, and then we're going to connect the adjacent ones, and we're going to get what's called an inscribed quadrilateral. So we got that guy. All the vertices here of this quadrilateral are on the circle, right? So there is an inscribed quadrilateral. Okay, more generally, this would be called an inscribed polygon. A polygon means many sides. So any shape that has, or any polygon that has its vertices on the circle is an inscribed polygon. Since it only has 4 sides, we can say that specifically this is an inscribed quadrilateral. Now notice that the angles of the quadrilateral are all basically inscribed angles, okay, and they make these arcs. So that's kind of an important idea. In your book, there's another theorem here called the inscribed. Well, actually, it's called Theorem 10.8 in your book, but I just gave it a nickname because Theorem 10.8, it's not very descriptive. So I'm going to call this the inscribed quadrilateral theorem, but it goes something like this. And this is on page 548 if you want to look it up and check it out. But I'll give you the wording here. It's basically this. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Okay? That's the fact that you got to know, and you're going to use that fact on your homework as well. So let's say we got some angle measures in here. What this is saying is that the measure of angle 1 plus the measure of angle 4, opposite angles, equals 180. supplementary. Okay. Also, the measure of angle 2 plus the measure of angle 3 also has to equal 180. The reason why that's the case is if you think about the full circle, let's just look at two of the angles for a second. Let's look at angle 1 and angle 4. Okay. So here's angle 1. The arc for angle 1 is right there. If you look at angle 4, the arc for angle 4 is there, and we know these two arcs have to add to 360 because they go all the way around the circle. Okay, well remember that the inscribed angles are half the arcs. So if the two arcs add to 360, you divide that by 2, the two angles have to add to 180. Right? Again, it goes back to this idea, this inscribed angle theorem, that the inscribed angle is half the arc. Right? Well, if these two angles make a full circle, the arc measurement is 360, then the sum of the two inscribed angles must be 180, or half of 360. That's kind of where that comes from. Okay. Now let's use that fact on the homework again. Okay. So going back to the homework, we got some questions that you'll use that on. Let's see if I can find one. I think, yeah, number 8 was one of them. Okay. So here we got two inscribed angles, but they're opposite angles in an inscribed quadrilateral. So notice we got those 4 sides there. So what I know is that the opposite angles in a quadrilateral are supplementary. So I'm going to add these two guys together and set them equal to 180. When I do that, I'm going to get 19x minus 10 equals 180, and then we just need to solve. So 19x equals 190 when I add 10 to both sides, x equals 10. Okay, again, not what I'm looking for. I need an angle measurement, YCW. Okay, so I'm going to plug 10 in to that expression. So 11 times 10 equals 110 degrees. Okay. All right, now there's a couple on here that are kind of tricky because they require not just one equation, but 2 equations. So let's look at that, okay? I did number 11 in class, so I'm going to do number 13. And hopefully that's enough of an example. But let's take a look. So again, I have an inscribed quadrilateral. Opposite angles are supplementary. So I can set up an equation here. Let's use opposite angles D and T. Those are across from each other. So 5x minus 1 plus 53y equals 180. Okay? Now, that by itself doesn't really help me out a whole lot because I have an x and a y in the equation, which means it's going to be, I can't isolate one of the variables and have it be equal to a number. I can't really solve for x or for y and have it be x equals number, y equals number, because there's 2 variables. What I can do is I can write a second equation. Okay, so there's equation 1, I'm going to call this. And equation 2 is going to be using the other 2 angles. Okay, so 5x minus 4 plus 54y plus 1 equals 180. Okay, I got the second equation. What we call this is a system of equations. And if you remember back to 9th grade, you probably did a unit on solving systems and techniques for solving systems. What we need to do here is we need to pick a method to solve these. There's multiple methods for solving systems. Graphing is one of them, substitution is one of them, elimination is one of them. In this case, I think elimination works out kind of well. It's not the only thing that you can do, but it's one of the things that you can do. You can use substitution here as well. But let's do it with elimination. So equation 1, I'm going to just rewrite 5x plus 53y, so there's a 5x, there's a 53y. And if I add 1 to both sides, I get 181. So this is just equation 1 rewritten with the x and the y on one side and the number on the right-hand side. Okay. If I rewrite equation 2, I'm going to have 5x plus 54y. And then these combined will give me a negative 3. And if I add 3 to both sides to cancel that out, I'm going to have a 183. Okay? So combine these to get a negative 3, add 3 to both sides to get rid of that negative 3 on the left. Okay, now what we can do is a technique called elimination. Elimination is where you combine the two equations, you combine the like terms of the equations basically straight down in columns, and the goal is to get something to eliminate. If I try to add down the columns right now, I get 5x and 5x will give me 10x, I'm going to get 107y, and then I'm going to get like, I don't know, a really big number over here. And that's not really going to help us out. So what we do here in order to make this elimination work is we multiply one of the equations to get the elimination to happen. So in this case, what I'm going to do is I'm going to multiply by negative 1. Okay, that will make this into a negative 5x, which will cancel with this 5x. So let's take a look at that. So I got a negative 5x. Well, I'm just distributing this negative 1 here. Minus 53y equals negative 181. That's this equation, or equation 1. Okay, equation 2 is fine. I'm not going to change that guy. But now when I combine the like terms vertically for these two equations, the x's will cancel, which is what I want. So negative 5x and 5x, that's 0. 0x or 0. I get 1y right here, and then negative 181 and 183 is actually 2. Okay, so y is equal to 2. I'm halfway there because the instructions say to solve for x and y, and we're using facts about inscribed quadrilaterals to do that. All right, now I need to find x, and so what I can do is I can use this guy and plug it back into one of the equations that I had. I can plug it back into the original equations, or I can plug it back into these modified ones. It doesn't really matter. So let's take that y value and let's plug it into this equation. Again, it doesn't matter which one, but this one looks nicer. So 5x plus 54 times 2 equals 183. Okay? So 5x plus 108 equals 183. Subtract 108 from both sides. And if we do that, we're going to get 5x equals, I think that's 74? Let's find out. I might be off. 72. Oh, sorry, no. 183 minus 108. 75. Okay. So 5x equals 75. Divide both sides by 5. And you're going to get x is equal to 15. Okay, so there's two answers here, an x and a y. But the system of equations that you need to set up comes from the idea that the opposite angles are supplementary. Okay, so that's kind of an example of how to do one. That's how you're going to set them up, and I'll help you set up one more just for practice. Okay, so let's look at number 12. Okay, we're going to take the opposite angles and add them together, and we know that has to equal 180. We're going to take these opposite angles, 40y plus 5x plus 25 equals 180. Okay, and we're going to set those equal to 180. So add this and this, and we get 180. Okay. Now again, there's multiple ways to solve this. Another method is substitution. Since this guy equals 180 and this guy equals 180, you can actually set these two equal to each other. Okay. In this case, that will work because the x's will go away, and sometimes that doesn't always work. It will, I think, in these four, but yeah, there's multiple methods. I'm just going to stick with elimination because in my experience that's the easiest one for students to understand. So let's go back to this guy. So this is equation 1, this is equation 2. We just need to rewrite them. Okay, I want kind of the x's and the y's on the left, and I want the numbers on the right. So equation 1 is going to be 5x plus 47y. Okay, now if I combine the 10 and the 1, I'm going to get 11. But I don't want the numbers on the left-hand side. I want them on the right-hand side. So I'm going to subtract 11 from both sides. So equation 1 is 5x plus 47y equals equals 169. Okay, we're going to do the same thing for equation 2. So here's equation 1. Equation 2, when I combine like terms, I'm going to get 5x plus 40y plus 25 equals 180. Okay, x, y, and then the number. Subtract 25 from both sides. And I'm going to get 5x plus 40y equals, I think it's 155. Yeah. All right, so we got equation 2. Okay, now these are your two equations. Sorry, this isn't a negative. That's a scribble. I messed up there. These are the two equations. You want to be able to combine them in a way that eliminates one of the variables. And since we have 5x and 5x, it will work if one of these 5x's is negative. So what we can do is we can multiply one of the equations by -1. It's not always -1 that you multiply by. I think it may be in these 4 problems, but in general, you're just looking for anything that's going to cancel for you. So let's rewrite equation 1. That hasn't changed. Okay. Right underneath that, let's write the new equation 2. So negative 5x minus 40y equals negative 155. Now this is ready for elimination because when I combine down this way, I get 0 x's. I eliminate the x's. That's what I wanted. Okay, when I go this way, I get 14. Okay, and so y is equal to 2. Now that's not my final answer. It's part of my answer, but I need to take that y and I need to plug it back in one of these two equations in order to find out what x is. You can also plug it in up here, the original equation 1 or the original equation 2. Doesn't really matter. You can plug it into this version of equation 1 or this version of equation 2 or either of these. But when you plug it in, you'll just have x's and then you can solve for x. Okay? So hopefully that gets you started. We got 2 main ideas from section 10.2, theorem 10.5 and theorem 10.8. Again, this is all coming from this section in your textbook. And that starts on page 544. So you can go check those out if you need to, if you want to get a little bit more background on some of these theorems or whatever, and where they come from. That might be a good idea if you miss class. Those are the 2 ideas that we're using in this homework assignment. Thanks for watching.